Here is the test with its solutions. Number one, solve by the square root property. So you're taking the square root of both sides, which means you're doing plus or minus square root of 81, which of course is 9. And then you split this up into two equations. 2x minus 3 equals positive 9, and 2x minus 3 equals negative 9, and then you solve accordingly. So 6 and negative 3 were the correct answers, but of course, all the work has to support the solution. Number two, solve by completing the square. And when I talked about this, I always talked about kicking over the constant on the other side of the equal sign and then completing the square. So to complete the square, you have to take half of b and square it. So half of negative 8 is negative 4. If you square that, you get 16, which is why this blue number represents me completing the square. The red 16 represents me keeping the equal sign, because whatever I do to the left, I have to do to the right. And then the rest is just consequences of this first line. 7 plus 16 is 23. This trinomial, remember, is a perfect square trinomial, so it factors into x minus 4 times x minus 4. And now it's just like number one. You square root both sides, keeping plus or minus, split it into two terms, and you get your two answers. It's best to write that as 4 plus or minus red 23, but separating them is full credit. Number three, figure out the discriminant and tell me what it means. So the discriminant is b squared minus 4ac when the quadratic equals 0, which what this one does. So 7 squared minus 4 times 1 times 6 is 25, and 25 is a positive number, so there are two real solutions. If 25 were a negative number, there would be two imaginary solutions, and if this were 0, there would be one real solution. Number 4 is not a function because 2 goes to two different y values. Functions only have one rule. Every x value has to go to one y value, and that doesn't happen here. Number 5. I forgot my pointer. You have a function, and you have to determine what is f of x minus 1. So all the input values get replaced with x minus 1. So that's 3 times x minus 1 squared minus 4 times x minus 1 plus 2, which is what all of this is. The rest is just simplifying. X minus 1 squared is x squared minus 2x plus 1. You distribute the 3, combine like terms, and you ultimately get 3x squared minus 10x plus 9. For number 6, here's another function, and you have to evaluate f of 2. In other words, when x is 2, what is y? So all the x's are the holders of the input, and the input is 2. So this, you get 2 squared minus 3 divided by 2 cubed minus 6 times 2. Evaluate, and you get negative 1/4. Number 7 is decreasing. You always read it from left to right. So this is decreasing all the way from negative infinity until x is 3. So that's the interval when it's decreasing. Number 8 is another multiple choice. You need to find the relative max and min. Now this function doesn't have a maximum, it goes up forever, nor does it have a minimum, it goes down forever. But it does have a relative maximum and a relative minimum. At 0, 1 for the max and 2, negative 3 for the min. So choice D. Number 9, is it odd or even or neither? The only way to determine this algebraically by showing work, in other words, would be to replace x with the opposite of x. And the opposite of x squared plus the opposite of x to the 4th power. All those negative ones cancel out, leaving you with this, which is the original. So it is even. Replacing x with their opposites and resulting in the same y value means you have an even function. And even functions are symmetrical on the y-axis. Odd functions are symmetrical about the origin. This function is not symmetrical on either one of those things. It's clearly not symmetrical on the y-axis, but the origin, it's not symmetrical either. First of all, 0, 2 is an ordered pair. If you reflect it over the origin, you would get 0, negative 2, and 1, that would make it not a function, and 2, the ordered pair isn't there to begin with. So this function is neither odd nor is it even. 11, you're evaluating h of 2. This is a lucky break because when h isn't 2, you have to do this nasty thing. But when x is 2, you have to do this, 2 plus 2. So 4 was correct. Now we're into the lines, it looks like. Write an equation in slope-intercept form that goes through these two ordered pairs. Well, first things first, we have to find the slope. So y minus y over x minus x, so you get negative 1/3. And then there's a few different ways to do this, but I put it into point slope form and then solve for y, getting negative 1/3 x plus 11/3. And since you have 2 points, 2, 3, and 5, 2, you can use either one of those since they're both on the same line, and that should result in the exact same answer. 13. Write an equation of a line in its point slope form that goes through 1, negative 6, and with this x-intercept. Well, if the x-intercept is negative 1, that's another ordered pair, namely negative 1, 0. So you have 2 ordered pairs again. So this is really similar to number 12. You can use these 2 ordered pairs to find the slope, which in this case is negative 3, and then you have 2 options as to what point you want to use for your point slope form. So either one of these was full credit. Number 4, x equals 3 is a vertical line. The way to remember that is every ordered pair on here, every single one, they'll have one thing in common. The x value is 3. 15, determine the slope and the y-intercept. So make sure to answer the question. You have to find the slope and the y-intercept. So here are my answers. The slope is 12/11, the y-intercept is negative 12. And all this is work supporting it. The way I did it was to take this equation and solve for y. So I subtracted 12x, added 132, divide everything by negative 11. The negatives cancel out. 132 divided by 11 gives you that negative 12. 16. Oh, good, a multiple choice. Graph this by using intercepts. Well, here's the line, the linear function. If you let x equal 0 and determine y, you will find the y-intercept. And if you let y equal 0 and solve for x, you will determine the x-intercept. And choice B had those 2 intercepts. So choice B was correct. Final page, number 17. A solid line contains the point negative 1, 4 and is perpendicular to the dotted line that has an equation y equals 2x. So what is an equation of line L in slope-intercept form? Well, I know line L is perpendicular to this. So that means line L's slope is the opposite reciprocal of 2, this line's slope. The opposite reciprocal of 2 is negative 1/2. And since it goes through negative 1, 4, I will use that point in my point slope form right here. And the answer needs to be in slope-intercept form, so I solve for y, and I get negative 1/2 x plus 7/2 as my final answer. 18, write an equation of a line in the indicated form. This is slope-intercept form again, parallel to negative 5x plus 8. So if it's parallel, it has the same slope, negative 5. And if it goes through 4, negative 4, then I use point slope form to start off, simplify a little bit, and then solve for y. I get negative 5x plus 16 as my final answer. 19, the average rate of change. Well, too bad it's not aligned because lines have a constant rate of change, and you would just say the slope and get full credit. But f of x is not a line, it's a radical. So its y values are always changing. The change itself is always changing. So the best we could do now without calculus is to find the average rate of change, which basically means find the slope of the secant line that's going through this function at these 2 points, x equals 2 and x equals 8. So you essentially find the slope of that. Notice the slope formula right here, y minus y over x minus x. So f of 2 minus f of 8 over 2 minus 8, and you get 1/3 as the average rate of change between these two x values. It doesn't matter where you start. You could have done f of 8 minus f of 2 just as long as you're consistent on the denominator with 8 minus 2, and you would still get 1/3. And perhaps the most algebraically exhausting one was number 20, the difference quotient of this function, which is essentially finding the derivative of this function, or if you find the limit as h approaches 0, this would be the derivative of this function, but you are replacing all the inputs with x plus h. So it's x plus h squared plus 9 times x plus h minus 2. That's this first part. And then you're minusing minus f of x. Well, f of x is composed of 3 parts. So if you're minusing these 3 parts, you need grouping symbols. I don't care what you use. I use brackets. You can use parentheses or braces or giraffe necks, anything that groups these 3 things together. And from here on out, the rest is just algebra simplifying. So x plus h squared gives you this trinomial. If you distribute the -1, you get this new trinomial, negative x squared minus 9x plus 2. Lots of wonderful things happen here. Negative 9x cancels out with positive 9x. Negative x squared cancels out with plus x squared. Negative 2 cancels out with positive 2. And what's left standing but 2xh, h squared, and 9h, all divided by h. All 3 of these have an h in common. You factor that out. These 2 cancel, leaving your final answer here. But all the work supports this.